select the chess pawn and enter the Modify mode. As you can see, the chess pawn is a typical sub-D mesh. Thus, it functions as a sub-D mesh. For example, manipulation of mesh vertices. Normally, commands such as booleans and fillets would not work on this sub-D pawn because it is not a NURBS model. But Power sub-D to NURBS is a novel unification piece between the NURBS and sub-D technologies. Before the Power sub-D to NURBS conversion takes place, we recommend smoothing your model to get the most successful of results. On your editable poly, use at least 2 iterations of NURBS subdivision located under the Subdivision Surface dropdown. From the modifier list, select the RE modifier, which will convert our polygonal model into a CAD-compliant NURBS format. Use the general settings for the Power sub-D to NURBS conversion and update the model. Power sub-D to NURBS runs on a credit basis where you are deducted credits based on the size of your model and its geometric complexity. This model will cost 9 credits to unlock. You can buy or add more credits as needed. You can also choose to preview your model at a 0 credit cost. However, your model will remain in a locked state, and you will not be able to perform NURBS operations to it until it is unlocked. If you have the unlimited version of sub-D to NURBS, no credits are required to unlock a model at any time. On average, the typical Power sub-D to NURBS conversion costs about 2 to 10 credits per model. Now that we have unlocked our model, it has all the properties of a traditional NURBS model. At this point, be sure to save your file. Now we will perform another Power sub-D to NURBS conversion to a different model to ensure that you can easily understand and complete the conversion process. As you can see, this rook is a typical sub-D model. As such, select the top faces of our rook to perform a slight bevel outward. Power sub-D to NURBS allows us to combine polygonal modeling techniques with NURBS modeling in a revolutionary way. Normally, a typical workflow would not allow for the combination of polygonal modeling with the engineering analysis and manufacturing design process of CAD operations. But Power sub-D to NURBS allows for the combination of the two. Now that we have beveled some faces, smooth the entire model using at least 2 iterations of NURBS subdivision in preparation for a smooth and successful conversion. Then, from the modifier list, select the RE modifier, which will convert our editable poly into a NURBS model. Use the general conversion settings and update the model. This model will require 6 credits to unlock. Unlock the model. Before exporting, you may want to apply an editable NURBS modifier to verify that the model has no open edges, which means it is a solid. The Power Edit NURBS tool can also be found under the NPower Tools 1 dropdown. As you can see, the model has no open edges, which means it will import as a solid into a CAD program like Autodesk Inventor. Export as a .step, which is a standard CAD translation type. You can also export as IGES-SAT or any other NURBS format. Let's repeat the exporting process using our sub-D to NURBS pawn. Apply an editable NURBS modifier to show the model is a solid with no open edges. We can clearly verify that the model has no open edges. Export as a .step. Next, open a CAD program like Autodesk Inventor, and open our newly exported pawn.step file. In Autodesk Inventor, the gray color of our model indicates that it is a solid. Next, you can open our newly exported rook step file as well. You can also export from Autodesk Inventor. Import your exported Rook file into your chess pawn Autodesk 3ds Max scene, or vice versa. For now, align the chess pieces with one another. Create a standard box to sit beneath our two chess pieces. With the length of 10, the width of 50, and the height of -50. Position the newly created box as desired. Remove the view of the grid by pushing G on your keyboard. Change the color to better see the results. Select the Power Fillet tool. The Power Fillet tool is also located under the NPower Tools 1 drop-down. Under the Power Fillet parameters, choose Face Select, and select the top face of the square box. Adjust the radius distance of the fillet set to 4.0 with a blend scale of 1.0. And select Show Fillet Result to see the result. Next, choose the PowerShell tool. The PowerShell tool is also located under the NPower Tools 2 drop-down. Choose the Pick Faces option under the Shell Parameters rollout and select the bottom face of our square box. Set the shell distance to -1.5 and click on Show Offset to see the result. You can also set the shell distance to -3.0 to see a different result with shelling if you prefer. Select and position the chess pieces where you desire on your newly created base. Now position the pieces slightly further into the base. We will next be using the Power Boolean tool to unite the base with these two chess pieces. Select the base and choose the Power Boolean tool. Set the operation to Union, select the Start Picking button and choose the chess pawn. And now select the rook as well. Now you can apply an editable NURBS modifier to verify that your model is one solid entity. Our model has 0 open edges, is one element, and one volume. Export your model as a .sat file this time. Open a CAD program like Autodesk Inventor to read in the new model if you so wish. Bringing your model into a CAD system allows you to perform traditional CAD operations, which, as you have seen, can also be done with Power NURBS and Autodesk 3ds Max. You can go back and forth between these systems to edit your model as you like. The process is flexible to suit you and your design preferences. Rotate the pawn 180 degrees. And align with the rook. Next, we are going to Boolean these two pieces together to create the base of our queen chess piece. Select the base, or rook, and choose the Power Boolean tool. Set the operation to union, choose Start Picking and select the pawn, or top. Scale to lengthen the model. Create a standard sphere in the top viewport. Align to the top of our queen chess piece. Select the queen, or base, and choose the Power Boolean tool. Set the operation to union, choose Start Picking, and select the top sphere. Create another standard sphere in the top viewport, slightly smaller in size. Align to the top of our queen chess piece. Scale the sphere to the shape and size you desire. Select our queen chess base, which is now composed of our Booleaned rook, pawn, and sphere. Choose the Power Boolean tool. Set the operation to union, choose Start Picking, and select the upper sphere. Create a standard torus in the top viewport. And align atop the queen chess piece's head. Scale to fit perfectly. Change the color to better see the results. Move slightly upward, and scale more if needed. When you are content with your results, convert your torus to an editable poly. We will next be moving several faces on our editable poly to create a crown for our queen chess piece using polygonal editing. Left-click on the Snaps option to bring up the Grid and Snaps settings. Under the Home Grid tab, set the grid spacing to 12.0. Under the Snaps tab, select the checkbox for grid lines. Turn snapping on. Move and snap the selected face to the closest grid line. Repeat this process for every other face along the same row. Turn snapping off. Select the middle faces along the row. Select multiple faces at a time by holding the control button on your keyboard down. And bevel outward. Adjust height and outline as desired to create jewels for the crown. Bevel again from our already selected faces. Select the top faces of our crown and perform another bevel outward. Bevel again. Smooth the crown by applying 2 iterations of NURBS subdivision. Select RE-Mod from the modifier list to convert our sub-D crown into a NURBS model. And choose to update. Unlock the model for 2 credits. Select the crown and choose the Power Boolean tool. Set the operation to union. Press the Start Picking button and choose the Queen base. Create another torus in the top view. Move and scale the new torus accordingly. And convert to an editable poly. Apply 2 iterations of NURBS subdivision. Select every 4th face along the same row. Bevel outward and adjust height and outline. Move the entire torus slightly upward. And from the modifier list, select RE-Mod, which will convert our sub-D model to a NURBS model. Update. And unlock your model for 2 credits. Even after you have converted your sub-D model to a NURBS model by applying the RE-Mod modifier, you can still edit the underlying mesh if needed. Select Editable Poly under the RE-Mod list. And select another face on your model to bevel. Return to the NURBS format of your model to see the update. And re-enter the Editable Poly mode to perform more polygonal operations. If you edit your underlying mesh with multiple amounts of operations, your model may require more credits to reconvert again. Choose to bevel several more of the faces before returning again to the NURBS format of your model. And bevel outward. Due to the vast amount of changes we have made, our model will need to unlock and update again once we return to the NURBS format. Unlock the model for 2 credits. Next, make sure your newly converted torus is selected, and choose the Power Boolean tool again. Set the operation to union, press the Start Picking button and choose the Queen base. Create our last torus in the top view. Move and scale the new torus accordingly. And convert to an editable poly. Apply 2 iterations of NURBS subdivision for smoothing the model. And select some faces to bevel. Bevel. Convert to a NURBS model using the REMod modifier. Update and unlock for 2 credits. Next, select the newly converted torus and choose the Power Boolean tool. Set the operation to union. Select Start Picking and choose the Queen chess piece base. Even after we have performed a Boolean operation to our sub-D to NURBS model, we can still go back to the original mesh and edit it accordingly. For example, when we move the positioning of the faces along this row, sub-D operations and changes can be done before or after a NURBS conversion. Thus, Power sub-D to NURBS marries the 2 technologies together in a unique way. Next, choose the Power Fillet tool. Select Edge Selection Mode and choose an edge to fillet. Adjust the radius distance to 0.2 and show fillet result. Apply an editable NURBS modifier before our export to verify that the model has no open edges. Export as a dot step. Open the Queen step file in a CAD program like Autodesk Inventor. Bringing a model into a CAD system allows us to perform traditional CAD operations, which can be performed in Autodesk 3ds Max with Power NURBS. We can also edit and perform some of these operations in Autodesk Inventor. Select Fillet and select the desired edge you wish to fillet. Change the radius of the fillet to 1.125. Fillet more edges. As you can see, filleting can be done in Autodesk Inventor or with the Power Fillet tool in Autodesk 3ds Max. Power sub-D to NURBS allows for a flexible process. Export as a dot step file. Open our Boolean, Rook, Pawn, and Base Autodesk 3ds Max file and import our newly edited Queen chess piece. Select and rotate the newly imported queen chess piece. Sit the queen chess piece upon the base to be booleaned later. Rotate the piece as needed. Select the queen chess piece and choose the Power Boolean tool. Set the operation to union, choose Start Picking, and select the base. Apply an editable NURBS modifier and verify that there are no open edges. Expand the Power Edit NURBS options and select Face. Though our model is one solid, we can set different materials to each face or group of faces. Under the Face Display Parameters rollout, notice that the material IDs are set to different corresponding sections of our model. Select the top face and set it to the material ID number 4. Select the bottom group of faces by holding the Control button on your keyboard down. Set the bottom group of faces to the material ID number 1. Next, choose the Render Setup options. Assign the Mental Ray Renderer and choose Viewport Background Color. Enter the Material Editor. Select a multi-sub-object material template, which will allow different materials to be assigned to each face or group of faces on our model. And from the Material Library, choose your materials. Select Glass, Light Bulb Off, Plastic, Low Gloss Black, Metallic Paint, Reflective White, and Metal, Copper. Drag the multi-sub-object material onto the model. Position your model as desired. And render. You can also adjust the order and assignment of materials to your model as well. And render. Because Power NURBS does the work to make a watertight STL compliant file, we can use it to rapid prototype and make a physical copy of a digital model. Export your file as a .stl, which is a format used for rapid prototyping.